Welcome to Inside Builder channel, large language model automators, Python experts, and my dear friends. Mastering topic modeling and cluster naming. Automating topic identification based on the documents that you have already clustered. We will be using the Bertopic library in this particular discussion. This particular discussion is an extension of the clustering algorithms that we are discussing in the earlier videos. If you are new to this particular discussion on the large language models, the sentence transformers, etc., I would suggest that take a look at this particular playlist, Mastering NLP with Hugging Face. And if you go down to the to the end of the playlist, you will be able to see these discussions that is happening on the embedding models and sentence transformers. This particular videos are kind of a primer for this the discussion that we are having right now. With that said, let me dive into the discussion. So what are we trying to achieve? Let me try to give you an overview. Before I start going into the theory, let me share you the output, what we can expect from this. Let me go down, and what you see here is made of sentences. The scatter plot that you're looking at in the video is made of sentences that is segregated into topics. So the rows or the pink color dots are a particular type of topics sentences. The blue is kind of a topic sentence, and yellow is another topic sentence. Group of sentences, and all these sentences have are the reviews that has been written by people in help.com. You might be thinking, how did the reviews that is written in text format has been converted to this 3D plot? Not just that. After you convert this to 3D plot, you can actually take the data out and you can plot the data anywhere else also. So what I've done here is whatever points that I've got here, you see the x coordinate, y coordinate, and z coordinate. This coordinate can be linked directly with the help reviews that you have seen that I showed at the beginning. So let me go to the top. Let me now show you the data from where this particular output had come from. So the output had come from this text that you see here. The help.csv is shared with you guys in the GitHub repo. I'll be sharing you the link of this particular code as well as the data that I'm using, and also the updated data. This particular help.csv has the reviews that is in text format, and it has also got the stars, so 5-star and 4-star, etc. This particular text format has been converted to embeddings. So the conversion of the embeddings is what I'm going to first of all show you guys. So in order to convert the text into embedding, you have to import the sentence transformers, and you have to take one of the models that is available in the sentence transformers. I have taken all mini LM L12v2 model. You can use all NP-net also. This mini LM is smaller model, so I have taken it smaller in size. In the size of hard disk space it takes, it's actually smaller and it's faster also. Keep one thing in mind: sentence transformers will need GPU if you are going to work with huge amount of data. That is, if you are going to work with 10,000 or 20,000 or even in thousands, if you are going to work with data points which is in spans in thousands, then better use GPU option. Here right now you see that I'm not using GPU option in this particular discussion. However, when I created this notebook, I used GPU extensively. And this particular notebook is not just about, I'll be going through the steps one by one, but I'm trying to dive into the important steps for you guys to understand why we are having this discussion. With that said, we have imported the sentence transformers model, and then we have to encode, meaning we have to convert this text data. Let me zoom in a bit so that you guys can see it better. This is a text data, so there are lots of information available in this review. Whatever you're seeing here is just a part of it because of the space constraint. For an example, I take this first review text data and I'm going to encode it. So what is the meaning of encoding? I have to just use this embed mini LM object, the same object that I initiated at the top, embed mini LM. I'm going to use that object and I'm going to use the encode method and I'm going to send the first review. So what is this review? This is the review that I was talking about that I got from the LPreview CSV file. This CSV file was shared by someone else already, so thanks to them. Here you see this is the complete document that you're having. Keep one thing in mind, this particular document may have a lot of information. So let me actually do one more check right now. All these checks are required. I will tell you why I'm doing this right now. Just give me a moment. So if I split this document into words, and if I check the number of words available, so I can use the split option and I can check the number of words available. In case of the sentence transformers model, the number of words that you can send into the model is around 450 to 480 words. So this particular review has 160 words, so it should not be a problem. All the review will get embedded. But if the review is more than the 480 words or 450 words, then the rest of the words will get truncated, meaning it will not get embedded. So keep this in mind. And when you are facing this kind of a challenge in your real world applications, you might have to separate the sentences into two sentences. So you have to segregate the review or the data into two sets of review so that you can embed both the things and later you can join them together. Or one more option is you can summarize the entire review into a smaller chunk using any of the summarization model. If you are new to all these concepts, I would suggest to take a look at these videos where I explain everything related to open source models, especially these top videos on both Hugging Face NLP models and vision tasks. Getting back to the discussion, so this is one of the this particular idea that I showed you right now is called a sequence length. So sequence length of the models that I'm using here is 512 tokens. Tokens is different from words. So most of the time the number of tokens and number of words are very close by. So if the tokens is 512 tokens is the sequence length, then when it comes to word counts, it will be 450 to 480. So the number of word counts that can be accommodated by the model is lesser than the token value or the token sequence length. So keep that thumb rule in your mind. It is a little bit difficult to give a formula for that because it all depends on the model, how the tokenization happens inside the model. So it's not a straightforward mathematical way of providing a formula for it. You have to be aware of that and understand. So there is a way to, once you do the encoding, right? Once you do this encoding, you can actually decode it and look at the data also. I'm not going to go into that step here, but you can do that. So if you're questioning that, Kamal, how will I know that model has done the encoding properly? So you have to decode it. So that is, I'm not going to discuss about that here. Let us proceed further. So once you encode it, you will see that I am getting all these numbers. So this numbers is basically the vectors or the embedding vectors. This is the numbers that is important, and this is the number that is going to convert into these plots. You see these plots here, this is going to be from those numbers. But one thing, this is one review. So I am sending one review and I am getting 384 numbers. So what will happen if I am going to send all the 10,000 reviews? Yeah, you're right. So all these 10,000 reviews are going to create its own 384 numbers. That is a huge amount of numbers, right? How are you going to process it? And moreover, here we see that I am only working on two dimensions, that is x, that is y and x axis. Same way here also x and y axis. I'm going to close this right now because it will conserve my resource. If I go down here in the notebook, I have used Plotly library for plotting the 3D scatter plot, and in the 3D scatter plot I'm using X, Y and Z axis. There are 3 axes maximum, and with 3 axis itself the model, the clustering of the points are looking okay. We are able to understand what is going on a bit, but what will happen if you are going to plot it on a 384 dimensions? Like here it is 1, 2 and 3 dimensions only. How will you even plot 384 dimensions? Okay, no, we are not going to do that. That is the work of UMAP. So the reason why I was discussing all this point is to show you why we need UMAP. So now you guys must be clear. So we started with sentence transformers, which created a large number of vectors, or to be a little bit precise, sentence transformers creates vectors that is having a length of 384 to 786 to, even in case of closed source models like OpenAI, 1536 elements per vector, meaning each line of text or each data point of text will have 1536 vector length embedding vector. When that is the case, how are we going to work with it? How are we going to tune the model? How are we going to do machine learning algorithms? That is where the idea of UMAP comes into picture. So UMAP basically reduces the 384 dimensions into 3 or 4 or 5 dimensions, whichever you want. So once you reduce that 384 vectors into 3 or 4 data points, meaning, let me go back again to the discussion, again to the Jupyter notebook. What I'm trying to say is that all these 384 vectors that we saw at the just a minute, let me zoom, all these 384 vectors will be converted to just 3 points by using the UMAP library. This is what UMAP does. I am really not going to dive into the specificity of how the UMAP algorithm works. There's a lots of discussion. You can visit this particular link that I have provided at in this particular presentation. You'll get a lot of information about it. And this particular algorithm has been developed by engineers working in Google research, and they've done a really wonderful job. This UMAP algorithm is right now used by Bertopic. So you understand how these things are coming together, right? Now the question is why we need to use UMAP. So let us go down the rabbit hole. We already saw that we have review data, or you might have some other data with you. You might have some customer information. You might have the documents that is available with you that you want to use it in machine learning, or you want to try doing something with the documents. So how to convert the documents into something that is readable by machine? Okay, converting the documents that is readable by machine, we already saw. We can do the embedding and we can convert it into numbers. But after you convert it into numbers, that is vectors of 384 length, how are we going to make the machines understand it? So that is where the idea of reduction of the dimensionality comes into picture. Reducing the 384 dimension vectors into 3 dimension vectors is called as dimension reduction. And for that, we will be using UMAP. After you reduce the dimension, you will create such clusters. You see there is red at the top, there is pink in this location, there is green in this location, and also there is dark green in this location, blue at the bottom. So all these are various topics. And how did these topics arise? When the sentences have been embedded by using the embedding algorithm, and then it has been converted to reduced dimensions using UMAP, the sentences that are similar, the sentences that have semantically same meaning, got clustered together. So what that means is, so if these sentences are all about food or pizza, it comes in this location. If it is all about cars and vehicles, it comes in this location. It's all about hotels and malls, it comes in this location. So the reviews by themselves have internal meanings, and that meanings are getting transferred to numbers, and it we can actually visualize it like this. This is the point of clustering. So I have been discussing this particular point in the earlier videos regarding the clustering. So there are various algorithms that is available, like k-means, agglomerative clustering, HDB scan, and various other algorithms for clustering the data. So you give this data points. Let me go back to the browser. You give the data points of all the 1,000 reviews that you have in L preview. You convert all these things and give it to HDB scan or k-means. It will actually cluster it and give you the cluster numbers, meaning it can provide you the topic, how many clusters it is there, and how many different types of clusters are there. It can help you to create the what is it called? Create such graphs, create such charts. But what we are after is we want such topics. You see this topic here, bar plays beer. So this is the first topic that is shown by blue, green, light green dots is about beer bars, and second is about barbecue. Third is about breakfast and non-vegetarian breakfast. And so like this, there are lots of topics that has been covered here, and each of these topics has been automatically identified. So this is what we are after. So there are lots of algorithms to create clustering using the data, but Bertopic helps to find out the topic inside the clusters, and that is the reason that the process which goes through process which has been used by Bertopic involves UMAP. So all these things are linked together. So that's why I'm going from the important point to the overview. Like I'm starting with the detail and I'm actually coming back to the real top level discussion, that is Bertopic. Now let us go back to the PDF. So in the Bertopic, what happens is, so Bertopic is basically a pipeline. So it starts by the sentence transform as input, and it uses dimensionality reduction using any of these. There are lots of dimensionality reduction algorithms. UMAP is one of the recent developments. Recent in the sense when compared to various other algorithms, this is recent. So, but yeah, there are this is pretty old algorithm from the chronological order. After you create the dimensionality reductions, that is sentence transformers create 384 or 786 or 1536 vector. This dimensionality reduction converts that to 3, 4 or 5 dimensions. Once you reduce it to that level of dimensions, you send it to HTB scan for clustering. Once you do the clustering, then you remove the stop words using various stop word algorithms like counter vectorizer. And then this is one of the key this is one of the contributions of Bertopic, that is class based IDF, that is class based term frequency inverse document frequency. This algorithm is part of Bertopic. This algorithm helps to locate or identify the topics, and once the topic has been identified, these topics can be represented by various methods. So by this particular step, we will be able to get the topics. But after you get the topics, if you want to fine tune the topics, then you can use various methods called as topic representation. This is the entire flow. We are going to go through this flow for a couple of examples and see how is the output. So this is the objective of this discussion. So you might be wondering, Kamal, why complicate it this much? What was happening is, whenever I was looking at the other discussions about UMAP, or when I wanted to understand about Bertopic, the major challenge I was facing is that they were giving a lot of theory about what is going on, but I was unable to visualize what is the final output that I'm going to get. Yes, I understand that I will be able to generate topics, but how am I going to use those topics, or what I will be doing with those topics, and how will I create value? I mean, at the end of the day, people who are, I need to help the third party like business people or the customers to make some decision. And how am I going to do that? that is where that particular question drove me to dive deeper and to understand these algorithms from a different perspective. And that's where I started explaining from the point of the output. So the output that we are going to look for is the actual representation of the data as 3D models, 3D scatter plots, which can be given or which can be shown to the business people, which can be shown to the customer for them to take decisions. So if I'm just giving some of the examples. So if someone in your organization wants to find out, okay, what are the reviews that is primarily talking about the food, they just want to identify that, because there are lots of almost 10,000 reviews, and they just want to discuss about those reviews that is talking about food. And you see there are lots of food related reviews, and yes, there are a couple of topics that is talking about store, car, it is talking about service, it's talking about Scottsdale, and it's talking about the place also. So now if someone wants to understand, okay, what are the reviews that is talking about the place, or what are the reviews that is talking about, say for an example, Chinese food. So if they want to drill down into those reviews specifically, then they will be needing these types of topic modeling. I hope that you got an idea why we are doing this, right? Now, let us go back to the PDF. See, this kind of discussion from the application point of view is very important, because nowadays with the advent of large language models, with advent of various artificial intelligence algorithms, it becomes very challenging for people who are entering new into this arena to grasp the applications. Because when you go to the tutorials, when you go to the discussion points or the web tutorials, we have to go through a lot of steps before we start seeing actual results, like the results that I'm talking to you right now. That you go to the browser, you render this Google Colab notebook, and finally you can tell someone that, okay, by using this topics, you are going to decide, you are going to help people to decide on finding the reviews that is about Chinese food. Probably that is one of the applications, or that is one of the requirement that has been posted to you. This is an example that I'm sharing with you. So it could be, you could actually have a different website, or you could be working on a different data set altogether, which might have a similar kind of an application. Or you might want to cluster the data that you're having, and you want to get the topic out of it, and then you have to do more analysis on that. So you will know why you are doing this. But to understand this, it takes a lot of time and effort. You have to do a lot of reading, and my intention or objective is to reduce that time. So yeah, I have to at least take 20 minutes of your time before I give you the clarity, right? But in case of when you go to the internet, when you go to any of the YouTube channels or any of the other resources, education technology resource, you see that they start with a lot of basics. They complete the basics, they complete the theory, and then they go into practical, and then they finally come to the application. And yeah, they talk about the application, but they don't talk it to a level where you guys, if you're from a business background, or if you're from non-tech background, to really get the gist of this. So I believe that you guys have learned one or two things from this particular discussion. To do leave a like, and do share it with others. Do subscribe to my channel for further updates on similar kind of discussions on artificial intelligence models, Python libraries, and open source ecosystem. So when I say ecosystem, I cover most of the things, irrespective of the software or hardware. I cover whether it is an open source library or a framework like LangChain, if it is like open source transformers, the library that talks about neural networks, yes, I cover that. Or if it is about databases, that is open source, and it is links with neural networks or artificial intelligence, yes, I cover that. So most of the things that is surrounding the open source ecosystem is covered. So I believe that you will learn a lot. So do leave a like and comment if you have any questions. With that said, let us further proceed with our discussion. We have seen how the topic modeling happens using C, TF, IDF. We have seen how we can do the visualization, etc. And we can see how we can represent these words. All this theory we have already discussed right now. Now, the interesting part is where you start doing the coding and you start practicing. The reason I always, come to this particular slide and you see this GitHub repo link. Most of my videos have this GitHub repo link where I share the link of the Jupyter notebook. The idea of this particular link is for you guys to take the particular notebook, go to Google Colab or your own Jupyter environment and start breaking the example. You need to try the example first. You need to get the output and then start using your data and see whether you can replicate a similar kind of an output. And once you can do that, bingo, you already learned that particular topic, and you can do a lot more going further. That's the intention. Let me continue further. Here in this particular discussion, there is a point of exploration also. Bertopic does not stop with just text topic modeling. It can actually do multi-model topic modeling also. You can send images and you can send text. You can convert it into embedding, and you can do the same process, UMAP, HTTP scan, CFTF, IDF, and you can get the topic modeling based on the images also. I'm not diving into that particular discussion in this video, but I would urge you guys to try it out after you understand this particular code. Okay, so let us go to the browser and start discussing the code. The code is going to be very simple because I've already explained to you everything. The code is going to be simple. This particular code starts by installing various libraries like transformers, sentence transformers, Bertopic, and safe tensors. I'll be explaining why I'm talking about transformers and safe tensors in a couple of minutes. Next, you are going to import the model, that is the embedding model. I'm using all mini LM. Then there are two data sets that is being used in this particular notebook. One is the 20 news groups data set, which has been introduced by the Bertopic author. So I go through that process and I topic model that data, and then I topic model L previews. I am going to let you guys to do the topic modeling for the fetch 20 news group. The data, the code is already available. All you need to do is just go through just execute the cells. What I'm going to do is I'm going to do something more important. First and foremost, ensure that you have got Hugging Face hub sign up. So sign into their Hugging Face hub, get their user access token, and log in to Hugging Face hub using this particular cell. What I mean to say is, once you execute this particular login cell, you will be asked to give the token. So provide the token, Hugging Face token, like this, and then you have to, so you can provide the token here. So if you go to the Hugging Face hub, get the token, and if you get login, it will log into your account. Why this is important? Because let me explain that in a couple of minutes. So next, what I'm going to do is I am going to go down. So this is all related to the fetch 20 news groups. So this particular data set is about the news articles that has been written, and the news articles are already having their own topics, right? But we are going to use the Bertopic to do the topic analysis or topic modeling. So I have used a couple of I have created simple functions here to do the embedding activity. So if you are using CPU, then using this embedding functions are a little bit better, so that it can save your embedding data. So here you see this particular function helps you to create the embedding and then save it to a pickle file. A pickle file has its own advantages and disadvantages. Disadvantages are something which is actually on the higher side. So pickle file, the size of the file will be bigger, and the pickle file has inherent security risks. So try to avoid running any of the pickle file that is provided by others. I have shared the pickle file of these these two steps, especially for 5000 embedded data and for all the embedded data. Both of this pickle file data is available in the GitHub repo. So you can find it out under Hugging Face AWS folder. However, I would urge that do not run any of the pickle file that you take from the internet until unless you clearly know that, okay, this particular pickle file is safe. Because pickle file can run arbitrary code in your processor, so that's why you have to avoid that. In my case, the pickle file has been created from this documentation only. You can, if you are confident, then you can use that. As we go down, you see that I have created all these things, and I have stopped the process here. So I have created the embedding and I have stopped it. After that, I have jumped into L preview. So this particular data is not still topic modeled in this notebook. The Fetch 20 news group is not modeled in this notebook. So I would suggest that you can continue this particular notebook after you go through this the next steps. Okay. So here what I've done is I have imported the L previews, and I have shown how to extract the text data, that is the review data, from the L previews into a list by using the toList method in pandas. And then I am encoding. So here I am showing the example of encoding. Here is where the actual discussion starts. So I am importing Bertopic from the Bertopic library. Bertopic is a pipeline, as I explained already. I need to give the Bertopic the various algorithms that needs to be used. So let me go back to the presentation. So what I mean by the various algorithms. So what kind of transformer model I need to use, what kind of dimensionality reduction algorithm, what is the clustering algorithm. All these algorithms I can provide. If I don't provide it, Bertopic will assume the default. So in this case, I have provided the vectorizer model that is based on count vectorizer, which will remove the stop words. However, rest of the algorithms like UMAP, the sentence transformer, etc., has been assumed, or it is using the default models. In this case, you see that I have created the model. I have done the fit transform. So once you create the Bertopic model like this, so you have to give the vectorizer, you have to give the language, you have to give these arguments, and you have to do fit transform. Keep this in mind. You have to do fit transform. If you do a fit, then what will happen is it will create an error once you run this. So use fit transform only. Once you run that fit transform on text review, this particular 10,000 reviews of text will be embedded first, and then it will be reduced in dimensionality. So you see this, right? This is telling you what is happening. So it is first embedding, and then it is reduced in dimensionality, and then it is clustered, and then the topic is getting modeled, and then out comes these topics. Once the model is fit, this is where I was talking about the Hugging Face Hub. So I was telling you guys to log into Hugging Face Hub, right? The reason is that once you do the embedding and the topic modeling takes a lot of time. So if you are using CPU, it takes at least 20 minutes. If you are using GPU, it takes 1 to 2 minutes. But still, it is a lot of time and a lot of resource. So once you log into Hugging Face Hub, and once you create the topic, once you model the topic like this by using fit transform, then you can save it to the hub. So saving to hub is very, very simple. This particular repo ID will be having your username. In my case, Kamal JP is my username, and this is the model name or the repo ID name. Once you use that, and if you use this particular method, you can push it to the Hugging Face Hub. So in this way, whatever you have done here, whatever work you are doing in this particular notebook can be recalled later. So that is the purpose of this. So do get yourself signed up into Hugging Face Hub and start practicing. Most important point, again, I insist in all my discussion, is that you have to practice. All these things might look either simple or complex depending on how you look at it, but once you start executing it, you will experience something totally different. That is the one of the beauty of machine learning and artificial intelligence, and also coding. In fact, people are, even I am very much afraid about coding. Yeah, believe me. So sometimes you don't understand what is going to happen, and once you don't understand, you you start being afraid. So only way to overcome this fear, and because of fear you will actually go into procrastination. So that is one of the main reason why people don't start coding. The procrastination can be overcome if you know what is going to happen. If you really understand, okay, this is the outcome, then you will stop procrastinating. So I believe that this particular insight also is going to help you. Let us go back to the browser. Once you have done all the work, it is better to push it to the Hugging Face hub. And here I am further trying to understand. So using the model.getTopicInfo, I can get the various topic details, the representation of those topics. Like each of the topic, you see that it will come up with a lot of topic. So basic, if I use only count vectorizer, it will come up with almost 98 topics. If I go down here, you will see that it comes up with 98 topics. Topic 98. That is because I have not used any kind of additional representation. So I will show you how to reduce the topics also. So here, by using visualize topics method, model.visualize topic, we can see, you can visualize the topic distances. So bar, music, drinks is at the top, that is topic 3, and inside topic 3 we have theater, movie, seats. So this is one of the difficult thing to understand for most of them who come new to the modeling or artificial intelligence or machine learning arena. The dimension or the location of this particular dot or particular bubble has no relation to the meaning. Okay. In fact, if for an example you might be thinking, how can topic bar, music, drinks, and place, night, so all these are linked. So bar is a place where we go at the night. Okay, but now if you go down a bit, inside that you see theater, movie, seats, etc. So how is bar and theater related? Actually no, it's not related. When it comes to the meaning of theater and bar, it is linked with entertainment. So that is why semantically these are together. Semantically, in the sense, in this particular dimension, through dimension, it becomes equal or close by. And if you come down here, you see that it is about food. This is about clothes, and here this is about sweets, and this is about again this is about something about Mexican and different kind of food. This is about Italian food. So you see that by looking at this entire, here is all the Indian and Japanese and Asian food. So you see that there is a semantic relation that is involved here. Like this, you can visualize the data, and you can see the clustering as a hierarchy. So this is also one of the points that that I want you guys to actually understand. All these things can be done automatically. You are not going to do any of these things manually. And you can visualize it as bar chart. You can see the various topics and what are the words inside those topics. This is also done automatically. All this were done with basic Bertopic instantiation. So I did not actually do any kind of additional modification in the pipeline. So I just used a vectorizer, count vectorizer instance, which removes the stop words in the text that we are feeding. Now, next what we are going to do is, we are going to bring in UMAP. This is the UMAP model that we are going to use. And UMAP, I am asking for 3 neighbors to be used, and the number of components is also going to be 3. So what I mean to say is, if I send the embedding model, so this is the embedding model. If I send, this will actually create 384 long vectors. So this is the embedding model, and if I send this 384 long dimensions vector into the UMAP model transform, I will get 3 data points out. So this is the point I want you guys to understand. So I send 384 points into UMAP model, I will get 3. Why? Because my components are 3. If you change it to 5, if you change it to 10, accordingly this will also change. So you can actually practice this. And next is this is for the dimensionality reduction. So you understand what is the dimensionality reduction, right? From 384 I reduced it to 3. And next is the clustering algorithm. So here I am talking about, reduce the cluster, do the clustering using HDB scan, and that is being done, and all these things are done in a pipeline. So I have UMAP model, I have HDB scan, I have embedding model, I have vectorizer, and I am giving all these things, and I am creating a new Bertopic model, and this is a custom model, and I am fitting it. So all you have to do to run the model is to just run the fit transform using the text review data that we already have, and then ensure that you push it immediately to the Hugging Face hub. So you need to keep a backup of it, as I always say. And now when you look at it, the number of topics are lesser in number. You see there is only 20 topics, and these topics make sense. It is having coherent topic names. If you go to the other topics, and once you start experimenting, you'll understand what I mean to say with your own data. So changing these values, changing these the number of parts inside the Bertopic instantiation, and working with number of components in each of the models like UMAP and HDB scan is the practice that you guys have to do. So you see the output right now. So based on this output only, I had created the 3D model that I showed you in the beginning. So these are all the various steps that I have taken using pandas to actually create the coordinates. And then I'm not going to go deep into that. If you are new to Plotly or pandas related discussion, I would suggest that take a look into other videos that discuss that specifically, and you will get a better idea. So this particular data I had used the Bertopic the custom Bertopic model. So this particular model that I had initiated using various HDB scan, UMAP model, etc. that was used for creating this particular 3D scatter plot. And the final idea of representation. So representation is okay. In the layman's term, what the representation model means is that once the topic has been identified by the Bertopic CTF IDF algorithm, the actual topic can be again fine-tuned based on the various keywords or various parts of speech. You can use large language models also to understand what the topic is all about, and you can make it to create the topics. So that is what the representation is about. There are various representation algorithms available. I would suggest you guys to take a look at the Bertopic documentation for further understanding. And once you create this representation model, you can add that also into the Bertopic pipeline, and you can fit transform it, and then you can always push it to the Hugging Face hub, and then you can do the same kind of. So you see this is further reduced. So previous one had 20 clusters, but this one is having only 15 clusters. So like this, you can, once you create different representations, you will start getting better topic outputs. So do practice, do explore that particular representation models, and try to understand it better. I believe that we have come to the end of this. So this is the various steps that is done by the Bertopic to model the topics. With that said, I would like to go back to the presentation. So I believe that you have understood the steps that is required for converting the raw data into topics, and not just stop there. You have understood how to use those topics, how to get convert the text into three-dimensional points in the scatter 3D plot. You have got a brief idea of how to go about that, and apart from that, how to use the topics that you find. That is one of the key takeaways that you have understood from this particular video. And I believe that you have learned a thing or two from this video. Do leave a like and share it with others. Subscribe to my channel for further updates on similar kind of topics and discussion on artificial intelligence, machine learning, and large language models. With that said, I would like to leave this video with 4 words, that is practice, practice, explore, explore. See you guys. Have a great time.